Welcome to this lecture on the basics of software, where we'll walk through key ideas that make modern applications work. Over the next slides, we'll explore how software is structured, how it's built and tested, and practical approaches to learning these skills. Think of this as a guided tour that connects high-level concepts to everyday developer practices in a clear, approachable way. This diagram shows a layered software ecosystem, where hardware sits at the base. System software like operating systems, drivers and firmware, manage resources, and application software sits on top to deliver browsing, gaming, or banking experiences. Developers build on these layers, and together they form an integrated stack that shapes performance, capabilities, and how users interact with devices. The software development lifecycle moves from planning and analysis through design, implementation, testing, deployment, and ongoing maintenance, with deliverables at each step to reduce risk. The goal is to align stakeholders early and produce artifacts that guide the team, so when code is finally written, it fits the intended scope and quality expectations and prevents costly rework later on. On the left, we have the waterfall approach, a sequential, document-heavy process that suits stable, well-defined requirements. On the right, Agile works, in short, iterative sprints with continuous feedback, user stories, and daily stand-ups. The key difference is that Waterfall plans up front while Agile embraces change, delivering value incrementally and allowing teams to adapt as requirements evolve. This slide highlights data and control flow. Programs store values and variables with defined types and manipulate them to produce results, while control flow constructs like conditionals, loops, and switches determine execution order and state changes. The visual diagrams make it easier to see how data moves through a program and how logic reacts to inputs and repeatedly processes information. Functions encapsulate reusable logic, taking inputs and returning outputs to simplify complex tasks, while modular decomposition breaks a large problem into smaller modules, like user interface, data processing, and database access. Together, these approaches improve readability, enable parallel development across teams, and make testing and maintenance far more manageable compared with monolithic code. Unit testing forms the base of the testing pyramid by isolating the smallest units of code, asserting expected behavior, and automating fast feedback. The pyramid emphasizes many quick unit tests, fewer integration tests, and minimal end-to-end tests, which helps guard against regressions, speeds up the development loop, and makes continuous integration practical and reliable. Effective debugging follows a simple cycle: reproduce the issue, form a hypothesis about the cause, instrument the code to gather evidence, and verify the fix before moving on. Modern IDE tools like breakpoints, watch variables, and call stacks shorten the path from symptom to root cause, letting you zero in on failures with less guesswork and faster resolution. Git provides distributed version control and collaboration with branching and merging workflows that let multiple developers work in parallel. Commits act as save points, and the commit history lets teams replay evolution to understand changes. Pull requests and merges help review work and integrate features safely while keeping a full historical record of how the codebase has evolved. DevOps unifies development and operations by streamlining the lifecycle with automation, infrastructure as code, automated builds, tests, and a deployment pipeline. The idea is to push verified artifacts into production frequently and reliably, reducing manual handoffs and risk, while enabling teams to release many times a day with consistent, repeatable processes and fast feedback loops. Microlearning boosts retention by delivering short, focused modules that learners can revisit over time, building knowledge incrementally. For developers, this can mean 5-minute videos and brief quizzes slotted between tasks to avoid context switching, which increases learning efficiency and helps translate curiosity into practical skills that are reinforced through regular, small practice sessions. A 5-step framework turns curiosity into demonstrable software skills by mapping goals to concrete projects, selecting aligned resources, scheduling spaced repetitions, measuring progress with mini assessments, and iterating based on feedback. This continuous improvement loop moves learning from abstract interest to practical competence, ensuring that knowledge is retained and applied effectively in real projects.